Thanks, Adam. We at IPD are really pleased to be part of this event that supports the Switchboard Manufacturers Association. Now, we've all seen some very exciting stuff this morning. In the best part of the morning, some big blow-ups, arc flashes, and short circuit testing, which is really exciting, I think. But I think it's important to take 2 steps back and see what causes this exciting stuff. And I'll tell you what it is. It's the boring stuff. Yeah? Temperature rise testing, or rather, failure due to temperature rise within switchboards. Now, with the new standard, we are aware that the stock of the new IEC 61439 standard, which, when you compare with the old standard, the 60439, there are a few changes, quite a few changes, and some of the main changes affect the way temperaturized tests are conducted in this new standard. Okay. So we've got Priyan, as Adam introduced him earlier. Priyan's come all the way just for this event, and he has got vast experience, been with LSTL for about 15 years, mainly as the electrical R&D manager. And I think over the last 4 years out of those 15, I think has been mainly devoted to testing switchboards to the new standard. I think done over 30 series of tests to the new standard for various board builders around the world. And he's going to share that experience with us. We've tried to keep it short, and it is a very interesting and technical topic, but we've tried to cull the slides down and to keep it as brief as possible. So Priyan's going to just touch upon those points that cover the new requirements or requirements to meet with the new standard of temperature rise. Yeah? And he's going to share some of that experience with us, but he's going to focus mainly on the temperature rise part of that new standard. Yeah? Priyan?
Thanks, Brian. I'll straight go for the presentation. Now first, the standard we are using, IEC 60439-1, it calls for type-tested assemblies and partially type-tested assemblies. These 2 words completely gone in the new standard. Because I will explain why first. In order to comply to type-tested assembly, it has to be 100% comply to the tested assembly. In practical situation, it will never happen. There will be slight changes, some additions, some additional compartments. So you can't have a type-tested assembly. So generally, it will be fallen to partially type-tested assembly. But in the existing standard doesn't give the proper guideline to comply to the partially type-tested assembly slot. So that is why in the new standard, there are 3 options given. Basically, we call it verification options. So when a panel is, when you build a panel, it has to be design verified panel. So there are 3 options. The first option is always, preferred option is the by testing. As in the previous standard, you can test it and then call it, okay, it's a tested assembly. And the next option is by comparing. When you have already tested the panel, you can compare it with the tested panel to the built panel. So if it is okay, then you can call it as a verified panel. And the next thing is by assessment. You can apply design rules, calculations. Those are allowed within some penalty margins. I will explain it in the coming slides. Okay, this is a very important table in the new standard. The standard we are using now is only having 7 tests to be done. But in the new standard, we have 13 tests to comply. There are some new additions to the test, to the complete list. That is, in the new standard doesn't have, the existing standard doesn't have the compliance for the structure, like corrosion test and lifting test. So those are the new additions. We have to comply to the structural requirement. And this particular table explains whether you can do it by test or do it by comparison or do it by assessment. So temperature rise options, there are 3 options in the new standard. So when you take a panel we have the compartments, we call it functional units, and then we have the main bus bars, and we have a dropper bus bars. So the first option is, as per the previous standard, it is testing the complete panel at once, applying a derating factor. So there's only one test. Even if you have a 630 amp breaker functional unit, you can derate it, you can draw only maybe 400 amps, and you can pass the test. The second option, it is actually when you have a 630 amp breaker, you have to draw 630 amp. That is, we have to first test the exact rating declared by the manufacturer, which was new, which was in the previous standard we don't need to do. But when we now have a functional unit with a 400 or 630 amp rating on it, we have to prove that particular rating individually. And then still in the second option, we have to do again the complete testing, the complete switchboard testing with all the breakers on. There's another option. So that is the last option, which is actually we have to do individual breaker, and we have to do the complete panel, and we have to do separately the main bus bars and dropper bus bars. You might think why, we should do the dropper bus bars. That is because, let's say if you have a breaker at the top 630 amp, the dropper bus bar is 1000 amps. When you are drawing 630 amp from the top, the bus bar is not fully loaded. So actually, you don't know exact rating of the particular dropper bus bar when you follow the second option. So when you do the third option, when you check the dropper bus bars as well, then you know the exact rating of the dropper bus bar, where you can keep as a data and you can start comparing with the newly built boards to get the verification done. This is temperaturized verification by comparison. When you compare, certain guidelines are given. First thing is, it has to be in the same functional group. If you have the breakers are in different molded case, different size. So it has to be, when you are comparing 250 amp breaker tested, it has to be a 250 amp breaker frame. And the next thing is, when you in your tested design, if you have a particular size, in the new design, the newly built panel, you have to have the same size, or you have to go over the size, let's say width, height, or depth. The third thing is internal separations. You have to have equal or less amount of internal separation. That is in order to make more airflow inside the panel. Less power loss per section. Let's say if you have 1000 watts per section, then the panel you are building, it should have either equal to 1000 or less. Device substitution, this is a very important topic. A lot of people will ask, okay, the new standard try to minimize the number of tests. Now, device substitution is allowed only for particular range of product. Let's say if you have tested with one breaker manufacturer, and if they have changed the product, their product series, still you can comply. You don't need to test, but you can comply if following things comply. Like it should be the similar device, the similar size, similar width and height, and same or less power loss, and same or less terminal temperature, because this information is available with the manufacturers, breaker manufacturers. So you can get this information and you can comply. You don't need to test it again. And same physical arrangement, where you have tested the width, the space and the clearances has to be same. And not only that, the short circuit testing also to be, you should comply. You should have the less let through and less peak short circuit current. Temperaturized verification by assessment. Now without testing, it's also allowed to call it a verified panel. This is the way. It's only single compartment assemblies only up to 630 amps, and multiple compartment assemblies only up to 1600 amps. Both assemblies should have 50% or more horizontal openings in order to comply to this requirement. You have louvers at the bottom and the louvers at the top. So the top louver air opening should be 1.1 times more than the bottom louver openings. Assembly should have only one section, so you have to comply. You can't have two sections for the assembly. Safety margins applicable is you have to 20% derate the panel, the whole the rating, and also the functional units, and you have to overrate the cables 25%. So when you calculate using IEC 890, you will get the temperature, what is the temperature of the top or near the breakers. So assembly is verified if the calculated air temperature does not exceed the permissible operating temperature of the device given by the manufacturer. Else still, we have done about 30 series of tests for the new standard from 400 amps to 6300 amps. Thank you.